All right. Welcome to rocket science here. Okay. These are all the same. So let's just take this thing apart. Okay. It's got 60 kilograms. That's its initial mass, right? Once it burns 48 kilograms of fuel, it will have 48 kilograms less mass. So its final mass, this is our initial mass, right? Our final mass is what could be 60 minus 48, right? Is 12 kilograms. So it starts off with 60 kilograms. It's going to end up with 12 kilograms. And that's what happens with these rockets. In fact, on the Saturn V rocket, it got so light that they actually shut off an engine to avoid making the astronauts black out due to the G-force. Okay, it burns 2.15 kilograms of fuel per second, right? And that's per 1 second. Remember that trick? With an exhaust velocity of 982 meters per second. So the first thing to do, thing number one, is to recognize that the initial mass is 60 kilograms and the final mass is 60 minus the fuel, right? So figure out how much fuel it burns is 12 kilograms, okay? Thing number two to figure out is the thrust of the engine, right? So we're going to do force times time, right? And so this is one of those kilograms per second ones. So we remember we put 1 second as the time. It's 2.15 kilograms is the mass that it burns in 1 second, right? The exhaust velocity is 982, right? And then that's times force. So force is going to equal this times this. So let's go 2.15 times 982. And that is 2111.3. Okay, so the force, the thrust of the engine is 2111.3 newtons. Now we've done so much work and we haven't even gotten an answer, but we're going to use this thing, right? We want the initial and final acceleration, right? So that requires cleverness, right? So let's find the initial. Okay, the initial acceleration, we got the rocket here. And our force up is 2111.3 newtons. We got that from here, which we got from here, right? And the force down, it's 60 kilograms, right? Because that's my initial mass, right? Got that here. And so the force downward is 60 times 9.8. Reliable sources say that that is 588. The lights just went off on me. Okay, so it's like, God, this guy's really boring. Okay, I'm sitting in Birch's room doing this. Okay, and then that's negative, right? And now we're all set. Now we can just set this thing up. We've got 2111.3 minus 588 is equal to 60 times A. So remember, this is the sum of the forces. We're using F equals ma. But remember, F is not just one of the forces. It's not this one or this one, right? It's the sum of those two, right? So it's take the thrust take away the weight is equal to ma. So 2111.3 minus 588. I get that answer. That's 1523.3 divided by 60. And I get 25.388. Right, so that's my initial acceleration, or 25.4 roughly, right? So now let's do the final acceleration. Let's see, final acceleration. So for the final acceleration, we've still got 2111.3, and therein lies the rub, right? The engines actually get more force because they warm up, but we'll just pretend that these guys stay the same, right? So 2111.3. But now it's only 12 kilograms. It's 12 kilograms because it was 60. It burned 48 kilograms of fuel because basically rockets are just containers to hold fuel largely, right? And so 60 minus 48 is 12. That makes the force down less, right? 12 times 9.8. 12 times 9.8 is 117.6. right? And now we're all set. Now we can set up our equation, right? The sum of the forces. This guy's down, so it's negative, right? This guy's up, so it's positive. So 2111.3 minus 117.6 is equal to 12 times A, right? So basically, I'm just doing F equals MA again. The sum of the forces, right? This guy's up, this guy's down, right? So 2111.3 minus 117.6 gives me 1993.7, all right? And then divide that guy by 12. 166.14, so there we go. Ta-da, which is our final thing there, right? Okay, now the rest of these things here are optional here. I'm gonna show you how to do them, but right now this is all that's going to be on the assessment. It'll be something like this one. And there's one other variation where I tell you how much fuel I burn and how much time, right? And then you just you use the time here for whatever and how much fuel there is, right? And get the thrust a different way. But this part is always the same. It's always thrust minus weight is m times a. Don't forget that the mass changes, right? So therefore the weight changes and the inertia changes, right? Which is why the acceleration dramatically increases, okay? So, go ahead and hit stop right now, but I'm going to keep going. If you're not already asleep, I'm going to do the rest of this thing, right? Okay. So now let's answer the question, what time do the engines burn? Well, if you have 48 kilograms of fuel, right, the time would be 48 kilograms divided by the rate. All right, so let's do that. Let's see, 48 divided by 2.15. It would burn for 22.32 seconds. Ta-da. This is not going to be on the assessment, but let's just go for it, right? And then if, what is the acceleration at t equals 10 seconds? Well, let's see, at 10 seconds, our change in mass is 10 times 2.15, right? Is 21.5 kilograms. We've burned 21.5 kilograms of fuel. We're not even halfway through the fuel, but that's it, right? So our new mass is, where do we put it? Here, put it here. Mass is equal to 60 minus 21.5, 38.5, right? And then now we're set. Now we can figure out for this rocket, right? Just like before in the previous part of the problem, right? The thrust of the rocket is still 2111.3. Okay, but we only have 38.5 kilograms. We did that because in 10 seconds it burns 10 times 2.15 is 21.5. 60 minus 21.5 is 38.5, right? Okay, so 38.5 times 9.8. The force down, is 377.3, right? And now we're all set. Now we can go 2111.3 minus 377.3 is 12 times A, right? Ooh, not 12. Good God, what am I doing? 38.5 times A. Let's do this. Okay, so 2111.3 minus the answer I just got, right? Divided by 38.5. 45.04. 389. Right? And then, okay, make a graph of the acceleration. What would we do? We'd have to graph this. I guess we'd have to say y equals, what would it be? It would be the force, right? So to be parentheses, right? 2111.3 minus, okay, what's our mass? It's going to be 60 minus 2.15 times x. All right, we're trying to make a graph here, right? Times 9.81, or 9.8, right? So So there's your net force, right? The force up minus the force down would be this, right? Okay, so minus that. Let's see, okay. And then that would be divided by, what would it be? Divided by the weight, or the mass, sorry, 60 minus 2.15 times x, right? So this is force divided by mass will give you acceleration. And you'd want to set your window to x would be 0 min, and I don't know, maybe do 22.3 min or max, right? And then your y would be maybe be 0, and then your max would have to be 166, or you could make it 200, right? So set your window like that, right? And you should get this nice graph of kind of a thing like that, curves upward. All right, are you asleep?